Welcome to Chapter 8 of the AEON-CASIMIR Dossier, where we dive deep into the heart of propulsion physics and field architecture. In this chapter, we explore how the AEON-CASIMIR system achieves stability across vastly different scales, from the tiniest quantum vacuum fluctuations, through mesoscopic plasma structures, all the way to the grand curvature of spacetime itself. This stability is not just a technical detail, it's the backbone that allows the craft to function as a single, coherent spacetime object. Let's begin by understanding the objectives and the critical mechanisms that keep the system running smoothly. Main goal of Chapter 8 is to define how the AEON-CASIMIR system maintains stability across all operational scales. With gravity redistribution already established, the focus now shifts to frequency governance, phase coherence enforcement, controlled decoherence, and managing harmonic bleedover. Without these mechanisms, the delicate Casimir-Einstein coupling would quickly collapse into noise, jeopardizing the entire propulsion system. This chapter formalizes the rules and strategies that keep everything in balance, ensuring the craft remains stable and responsive in any environment. The AEON-CASIMIR system operates across three dominant frequency regimes, each governed by different physical principles. At the nanoscale, quantum vacuum modes dominate, with frequencies ranging from 1012 to 1018 Hz. The mesoscopic scale is ruled by plasma oscillations, spanning 10.6 to 1010 Hz. Finally, at the macroscale, metric curvature dynamics take over, with frequencies from 10 to 10.3 Hz. These regimes are interconnected by a harmonic ladder, which locks them together and enables seamless energy transfer across scales. This multi-scale approach is essential for the craft's stability and performance. At the core of AEON-CASIMIR's stability is the master coherence condition. This is defined mathematically by a coherence functional, which ensures that all local subsystem phases are aligned with a global reference phase. For stable operation, the magnitude of this coherence must remain extremely close to 1, with only a tiny margin for error. This tight phase alignment is what allows the system to operate as a unified whole, preventing destructive interference and maintaining the integrity of the propulsion field. Energy transfer between different frequency scales is managed through a process called harmonic bleedover. This involves nonlinear mode coupling, where the frequency of a given mode is determined by integer multiples of a master frequency, plus a small detuning term. This mechanism allows nano-scale vacuum oscillations to influence macroscale spacetime curvature without causing instability. It's a delicate balancing act that ensures energy flows smoothly across all operational layers of the craft. Key feature of the AEON-CASIMIR system is the frequency lock between Casimir cavities and plasma rings. These plasma rings act as active frequency translators, ensuring that the plasma oscillation frequency is an integer multiple of the Casimir cavity frequency. This lock maintains continuous coherence between the vacuum stress and the electromagnetic control layers, allowing the system to respond dynamically to changes in the environment and maintain overall stability. Like traditional systems where decoherence is seen as a failure, in AEON-CASIMIR, it's a powerful control tool. By locally increasing the decoherence rate, the system can soften field gradients, dampen curvature spikes, and stabilize transition zones. This capability is crucial for maneuvers like soft landings, field shedding, and emergency gravity normalization. Decoherence, when managed properly, becomes an actuator for stability rather than a source of chaos. Vacuum noise, which can disrupt the delicate balance of the system, is actively suppressed in the AEON-CASIMIR craft. This is achieved through nested Casimir cavities, phase-inverted boundary conditions, and destructive interference of zero-point modes. The result is a quiet vacuum zone inside the vehicle, free from disruptive spectral noise. This quiet environment is essential for maintaining coherence and ensuring the smooth operation of all onboard systems. The AEON-CASIMIR system dynamically adjusts its coherence length to ensure that the entire craft remains within a single coherent spacetime domain. This is done by tuning the frequency bandwidth, so the coherence length always exceeds the size of the vehicle. By maintaining this condition, the craft operates as a unified object, with all its components synchronized in both space and time. Prevent runaway curvature and maintain macroscale stability, the AEON-CASIMIR system monitors the rate of change of effective phase. If this rate exceeds a critical threshold, the system automatically triggers decoherence, frequency detuning, or even a fallback to Newtonian mechanics. These safeguards ensure that the craft remains stable, even in the face of unexpected disturbances or extreme operational conditions. From the perspective of an external observer, the AEON-CASIMIR craft's frequencies may appear Doppler-shifted, but the fields remain causal and no radiation spikes are detectable. Internally, the system maintains a phase-locked reference frame, ensuring time continuity and instrument synchronization. This dual consistency is vital for both stealth and operational reliability, allowing the craft to interact seamlessly with its environment while maintaining internal order. Chapter 8 stability mechanisms are directly integrated with other critical systems, including the CASIMIR cavity stacks, gravity sidebands, and plasma control rings. This integration forms the backbone of the entire propulsion system, ensuring that all layers work together harmoniously. By stabilizing these components, the AEON-CASIMIR craft achieves unmatched performance and reliability in a wide range of operational scenarios. Even the most advanced systems can encounter failures, but AEON-CASIMIR is designed for resilience. If phase drift occurs, the system auto-relocks. Excess noise is managed by vacuum damping, and coherence loss triggers controlled decoherence. In the event of a power drop, the system shifts frequencies downward. All transitions are smooth and reversible, ensuring that the craft can recover from disturbances without losing stability or control. One of the key insights from Chapter 8 is that propulsion, at its core, is a frequency problem. By mastering the control of frequencies across all operational scales, the AEON-CASIMIR system achieves unprecedented stability and efficiency. This approach redefines how we think about movement and control in advanced propulsion systems, emphasizing the importance of coherence and resonance. Gravity control in the AEON-CASIMIR craft is achieved by maintaining coherence across all scales. This means that the system must keep quantum, plasma, and spacetime domains in perfect resonance. Any loss of coherence can lead to instability, so the system is constantly monitoring and adjusting to ensure that gravity remains under precise control at all times. Decoherence is often seen as a problem in quantum systems, but in AEON-CASIMIR, it's a stabilizing actuator. By selectively introducing decoherence, the system can dampen unwanted oscillations and prevent runaway effects. This controlled use of decoherence is a unique feature that sets AEON-CASIMIR apart from conventional propulsion technologies. For the AEON-CASIMIR craft to function as a single coherent object, vacuum, plasma, and spacetime must resonate together. This resonance is carefully managed through frequency locks and harmonic coupling, ensuring that all domains are synchronized. The result is a craft that moves and responds as a unified entity, with unmatched agility and control. Without the mechanisms described in Chapter 8, the AEON-CASIMIR system simply could not operate. Stability across scales, coherence management, and controlled decoherence are all essential for the craft's functionality. With these systems in place, the vehicle behaves as a single, coherent spacetime object, capable of extraordinary feats of propulsion and control. At the smallest scale, the AEON-CASIMIR system interacts with quantum vacuum modes. These high-frequency oscillations are the foundation for the system's energy dynamics. By governing these modes, the craft can tap into the fundamental fabric of spacetime, enabling advanced propulsion effects that go far beyond conventional technology. Moving up in scale, mesoscopic plasma oscillations play a crucial role in the AEON-CASIMIR system. These oscillations act as intermediaries, translating quantum effects into macroscopic phenomena. By carefully controlling plasma frequencies, the system bridges the gap between the quantum and the cosmic, ensuring smooth energy transfer and system stability. At the largest scale, the AEON-CASIMIR system manages metric curvature dynamics. This involves controlling the shape and flow of spacetime itself, allowing the craft to maneuver with precision and stability. By linking these macroscale dynamics to the underlying quantum and plasma layers, the system achieves a level of control that is truly revolutionary. A harmonic ladder is the key structure that locks the three frequency regimes together. By ensuring that each scale is harmonically related to the others, the system can transfer energy and information seamlessly. This interconnectedness is what allows the AEON-CASIMIR craft to operate as a single, unified system, rather than a collection of separate parts. Maintaining phase coherence across all subsystems is a continuous process. The AEON-CASIMIR system uses advanced algorithms to monitor and adjust phase relationships, ensuring that all components remain in sync. This enforcement is critical for preventing destructive interference and maintaining the overall stability of the propulsion field. When the system detects potential instability, it can introduce controlled decoherence to dampen oscillations and restore balance. This process is carefully managed to avoid disrupting the overall coherence of the craft. By using decoherence as a tool, the AEON-CASIMIR system can adapt to changing conditions and maintain optimal performance. Managing harmonic bleedover is essential for preventing unwanted energy transfer between scales. The AEON-CASIMIR system uses nonlinear mode coupling to control how energy moves from the quantum to the macro scale. This management ensures that the system remains stable and responsive, even during complex maneuvers or rapid changes in operational conditions. Plasma rings, introduced in earlier chapters, serve as active frequency translators within the AEON-CASIMIR system. By locking plasma frequencies to the Casimir cavity, these rings ensure continuous coherence and enable precise control over the craft's electromagnetic environment. This translation is vital for maintaining the integrity of the propulsion field. AEON-CASIMIR system is constantly working to maintain coherence across all operational layers. This involves real-time monitoring, dynamic adjustments, and rapid response to any disturbances. By keeping all components in sync, the system ensures that the craft remains stable and responsive, no matter what challenges it faces. The decoherence rate is a critical parameter in the AEON-CASIMIR system. By adjusting this rate, the system can control field gradients, dampen curvature spikes, and stabilize transition zones. This level of control is essential for safe operation, especially during high-stress maneuvers or emergency situations. Vacuum noise can be a significant source of instability in advanced propulsion systems. In AEON-CASIMIR, the spectral density of this noise is actively suppressed using a combination of nested cavities, phase inversion, and destructive interference. This approach creates a quiet internal environment, free from disruptive fluctuations. By suppressing vacuum noise, the AEON-CASIMIR system creates a quiet zone inside the craft. This environment is essential for maintaining coherence and ensuring the smooth operation of all systems. The quiet zone also protects sensitive instruments from interference, enhancing the craft's overall performance. AEON-CASIMIR system dynamically adjusts its coherence length to match the size of the craft. This ensures that the entire vehicle remains within a single coherent spacetime domain, preventing fragmentation and maintaining operational integrity. The ability to tune coherence length on the fly is a major advantage in complex environments. Maintaining a single coherent spacetime domain is essential for the AEON-CASIMIR craft's operation. By keeping the coherence length greater than the size of the vehicle, the system ensures that all components are synchronized and that the craft behaves as a unified object. This is a key factor in achieving advanced propulsion capabilities. AEON-CASIMIR system continuously monitors its stability envelope, watching for any signs that the rate of phase change is approaching critical levels. If necessary, the system can trigger automatic responses to prevent instability, including decoherence, frequency detuning, or fallback to classical mechanics. This proactive approach keeps the craft safe and operational. When the system detects that the stability envelope is being breached, it can automatically introduce decoherence or detune frequencies to restore balance. These responses are fast and reversible, ensuring that the craft can recover from disturbances without losing coherence or control. In extreme cases, the AEON-CASIMIR system can revert to Newtonian mechanics as a fallback. This ensures that the craft remains controllable even if advanced field effects are temporarily lost. The transition is smooth and reversible, allowing the system to return to full functionality once stability is restored. An external observer, the AEON-CASIMIR craft's frequencies may appear shifted due to Doppler effects, but the fields remain causal and no unusual radiation is detected. This stealthy operation is a result of careful phase management and frequency control, allowing the craft to move undetected through various environments. Inside the craft, a phase-locked reference frame ensures that all systems remain synchronized. This internal stability is crucial for maintaining time continuity and ensuring that instruments operate in perfect harmony. The result is a highly reliable and responsive vehicle, capable of complex maneuvers and precise control. All instruments on board the AEON-CASIMIR craft are synchronized through the phase-locked reference frame. This synchronization ensures accurate measurements, reliable data, and coordinated responses to any changes in the environment. It's a key factor in the craft's operational success. The stability mechanisms described in Chapter 8 are closely integrated with gravity sidebands, ensuring that gravitational effects are precisely controlled. This integration allows the craft to perform advanced maneuvers, such as rapid altitude changes or gravity normalization, with confidence and precision. Casimir cavity stacks form the foundation of the AEON-CASIMIR system's quantum control layer. By integrating stability mechanisms directly with these stacks, the system ensures that quantum effects are harnessed efficiently and safely, providing a stable platform for advanced propulsion. Plasma control rings are another critical component, acting as intermediaries between the quantum and macro layers. By integrating stability mechanisms with these rings, the AEON-CASIMIR system achieves seamless energy transfer and maintains coherence across all operational domains. All transitions between operational states in the AEON-CASIMIR system are designed to be smooth and reversible. Whether it's recovering from a power drop, managing excess noise, or relocking phase coherence, the system ensures that changes do not disrupt overall stability. This resilience is a hallmark of advanced field architecture. Summary: Chapter 8 establishes that propulsion is fundamentally a frequency problem. Gravity control requires coherence across scales, and decoherence is a stabilizing actuator. The resonance of vacuum, plasma, and spacetime as a unified system is essential for the AEON-CASIMIR craft's operation. With these mechanisms in place, the vehicle behaves as a single, coherent spacetime object, capable of extraordinary feats. Chapter 8 of the AEON-CASIMIR Dossier is now complete. The principles and mechanisms outlined here form the foundation for the craft's stability and performance. With this knowledge, we're ready to explore even more advanced aspects of propulsion physics and field architecture in future chapters. As we move forward, the insights from Chapter 8 will guide the continued development of the AEON-CASIMIR system. The mastery of frequency, coherence, and decoherence across scales opens new possibilities for propulsion and field control. Stay tuned for the next volume, where we'll delve even deeper into the mysteries of advanced field architecture.